This one has a lot of information on it, so we're going to blow it up full screen. What you're looking at here is up top the ECG, or the electrocardiogram, as well as heart sounds. Next part below it is looking at pressure. Now this pressure is looking at 3 different pressure points. You're having pressure of the purple here. That is the atrial pressure. You then have the blue, that's ventricular pressure, specifically left side here. And then green is the actual aorta. So looking at how the pressure changes from the left atria to the left ventricle to the aorta. Below that, looking at ventricular volume. This is how much blood is in the left ventricle. And it's the same as the right, but either way. The very bottom, you're looking at the AV valves and the semilunar valves. So looking at, are they open or are they closed? So let's start with the P wave. We know the P wave was the initiation of atrial systole or atrial contraction. Well, there's no heart sound with that, so there's nothing there. It makes sense. But if we come down, it's roughly corresponding, like not the perfectly straight line there, but it pretty much is the start of the atrial systole, which is contraction. You'll notice that the atrial systole has a little bump in pressure. As the atria contracts, it's creating a little bit of pressure inside the atria. And you say, well, the ventricle did too. Because as the atria contracts, it's pushing blood into the ventricle, which means the ventricle has a little blip or a little increase in pressure also. At this point, during atrial systole, it's ventricular diastole, or ventricles are relaxing. The AV valves are open, so bicuspid, tricuspid are opened. You then have the aortic and pulmonary semilunar valves, though, are closed. Because at this point, the semilunar valves are preventing backflow into the ventricles. All right. From the P to the R QRS complex, so PR segment, you'll notice that during the PR segment, the atrial systole here, pressure is going down because it's finishing up its job. It's pushing the blood out. There's nothing left. Which means we're now at the QRS complex. QRS complex, you'll see how it initiates, and then towards the end of the QRS complex, we have the first sound for the heart, that lub sound of lub-dub, lub. We know that that first heart sound is telling us that a valve or valves are closing. The question is, which valves? We're closing the AV valves. That means the tricuspid and the bicuspid valves are starting to close. We know they're closing because the ventricle is starting to contract. As the ventricle contracts, it's going to start to increase pressure in the ventricles. You can see that right here. That blue line is the start of the increase in pressure. The pressure of the ventricles are climbing. As that pressure inside the ventricles climbs, it's going to close the tricuspid and bicuspid valve to prevent backflow. But for this brief period right here, both the tricuspid, bicuspid, and aortic and semilunar valves are all closed because you haven't generated enough pressure to get the blood out of the ventricle. We're building the pressure. It's at this point right here. You can see where the blue line, the pressure of the left ventricle, crosses the green line, the pressure inside the aorta. You have to be able to generate enough pressure to push that aortic valve open and get the blood into the aorta. Now, once that valve opens, the ventricle keeps contracting. That's this whole ST segment. You keep contracting. And as you're doing that, you're increasing more and more and more pressure. So that's why we're going from the 80 millimeters of mercury up to the roughly 120 millimeters of mercury, because you continue ventricular contraction, which then ends when we hit this T wave. Now the T wave is going to initiate ventricular relaxation or ventricular diastole. So as that occurs, as the ventricle just starts to relax, that means it's starting to open up. The pressure inside the ventricle starts to go down. can see how this pressure is dropping right here. As it goes down, that second heart sound kicks in, because as the pressure starts to drop, you don't want the blood from the aorta coming back into the left ventricle. So that means the aortic valve, those semilunar valves, snap shut. That's the dub, the second sound. Then the pressure inside the ventricle just plummets, going back down to full relaxation. At that point though, notice the aortic pressure. It's still higher. It's higher than the ventricle. It's still decreasing because there's nothing creating pressure. But at this point, it's not dropping as fast as the ventricle because the semilunar valve closed, keeping the blood in the aorta. All right, let's go down to this ventricular volume area, which we didn't do much with yet. The EDV, end diastolic volume, that was the amount of blood in the ventricle at the end of relaxation. If you notice, that's right here before it drops. That corresponds right there. That EDV, the amount of blood volume in there, is just before you open up the aortic semilunar valve. At that point then, once enough pressure has been generated and you open the semilunar valve, the volume is decreasing in the ventricle because all that blood is being pumped out into the aorta. Eventually though, you hit the ESV, end systolic volume. That's the amount of pressure at the end, so the amount of blood at the end. So that means that's how much blood is in the ventricle at the end of contraction. So that's what you're seeing coming down here. Here's the pressure dropping, and we're matching it right to the ESV. Because at this point, you're not really pumping blood out. The semilunar valve is closed, and you've now got your ESV, end systolic volume. Overall, the difference, which is what you're seeing right here, is called your stroke volume. Stroke volume is end diastolic volume minus end systolic volume. Stroke volume is how much blood was pumped out of the heart per beat. So this whole idea of P, QRST corresponding to pressures, corresponding to ventricular volume, it's all trying to correspond to what we're seeing here. So this whole entire diagram, this whole chart, has a lot of information, but it's all correlated. You're looking at the intrinsic conduction system through the ECG, to the heart sounds, which are valves closing, to the pressure in the ventricle and aorta and the atria, to the volume in the ventricle, to when the valves are open and closed. All that corresponds to what is happening inside the heart at any given moment. So this is what we're looking at for our little bit of heart physiology. A lot going on, a bit to digest. So the heart itself working in rhythm, atria, ventricles, atria, ventricles.